Hello everyone and welcome back. So today we are going to learn what is subspace. We already know that what is vector space, and now we learn what is subspace. So before starting this particular lecture, so kindly you go and watch what is the definition of vector space. Otherwise you won't understand anything here. Okay. So first you see what is vector space and then just come to this particular lecture. Then you see that it's very easy. सो जनरली क्या था वेक्टर स्पेस में हमें मिला था V इज ए वेक्टर स्पेस ओवर द फील्ड F और वहां पे क्या था 10 कंडीशंस था V विल सेटिस्फाई 10 कंडीशंस. नाउ हियर वी हैव टेकन टू वेक्टर स्पेसेस V and W. V and W are two vector spaces and same definitions of vector addition and scalar multiplication. Now this is very important. Suppose in capital V it is given that a plus d equals to x, and in W if you write a plus w equals to y, then they are not identical. Okay, so in capital V if we add a plus d and if we get x, so this is just an example. Okay, if a plus d equal to x, then in W also a plus d should be what? X. Similar type of operation should be there. Similarly in case of multiplication. Now it is given that W is a subset of V. So here V is bigger than V is a vector space. W is also a vector space, but which is smaller? W. Now here W is a subset of what? V. Then we say that W is a subspace of V. So subspace is nothing but a vector space. Subspace is nothing but a vector space, but it is smaller or it is inside another vector space V. So पहले हमें दो वेक्टर स्पेस लेना होगा V and W, फिर हमें ये दिखाना होगा जो W V के अंदर है. So W is inside V. What does it mean? All the elements of W is also an element of what? V. तो सबस्पेस होने के लिए उसे खुद वेक्टर स्पेस होना पड़ेगा. Okay, so if W is a subspace, that means it is itself a vector space, and another condition is W must be a subset of V. अगर उल्टा हो गया, अगर V is subset of W, then V subspace हो जाएगा. So it's very simple. Okay, so subspace means it is itself a vector space. Just remember. Now let us see. Now to show that W is a subspace, means vector space, should we need to show all the 10 conditions? अगर W को subspace दिखाना है तो अगर 10 conditions दिखाना है तो बहुत लंबा हो जाएगा. So we already see in some examples that if we want to show that this particular set is a vector space, then we have to show all the 10 conditions. So here also if we want to show that W is a subspace and if we show all the 10 conditions, then the examples will be very big. So that's why there is a theorem. Okay, this is called testing subset for subspaces. तो यहाँ पे क्या है आप लोग देखिए सिर्फ 3 कंडीशन है, only 3 condition. So if W satisfy 3 condition, then automatically W becomes a subspace. Okay, the proof is not showing here. Okay, because for engineering and for mathematical physics students, the proof is not necessary. But I'll separately upload the proof of this particular theorem. So those who need it for like graduation and master students, so for them I'll prove it separately and just you go and watch this. This is a very simple proof. So what is the condition you see? V is a vector space. What is W? W is a subset. Okay, W is subset. Now W will be a vector space or W is a subspace. W will be a subspace if and only if 3 conditions satisfy. So what is the first condition? W should be non-empty. Okay, W is not equal to 5. W should be non-empty, and this is already given. W is a subset of V, or you can insert this condition here also. W must be a subset of V. So first is W is non-empty, means there is at least one element in W, and W is a subset of V. What is the second condition? It's very simple. This is the first condition of vector space. If we take any 2 element from W, add them, it will be again in W. Okay, so vector space का जो पहला condition यही था, अगर हम लोग W से 2 एलिमेंट लेंगे एंड इफ वी ऐड देम देन वो कहाँ पे आएगा, फिर से W में आएगा। और एक कंडीशन था 1 एलिमेंट फ्रॉम W एंड 1 एलिमेंट फ्रॉम फील्ड, मल्टीप्लाई करने से वो कहाँ पे आना होगा, W पे आना होगा। सिर्फ 2 कंडीशन। So if you see the definition, or if you still remember the definition, you see we are talking about the first 2 condition, closure property under addition and closure property under multiplication. So अगर वो 2 condition satisfy हो गया, then you say that what W is a subspace of V. So जब हम लोग examples करेंगे तो हम लोग यही use करेंगे, क्योंकि नहीं तो हमें we have to show all the 10 conditions, so that will be very very difficult. Okay, difficult means it's very long. Okay, now there is one more theorem where we need to show only one condition. Here too we have 2 conditions and basically 3 conditions, but first condition is very simple, it's non-empty, no need to show it, because one set will be given to us and it will be said that this is non-empty. So first condition is not necessary for us, second and third condition. But there is one more theorem. Okay, the proof of this particular theorem also I'll upload. So W is a subspace of V of F if just only one condition. I'll take 2 element from field and 2 element from W and combine them, alpha x plus beta y. We make a combination, and if this particular element comes to W, then you say that W is a subspace. So whenever we do some examples, we'll do those examples by this particular one operation, alpha x plus beta y belongs to W. Okay, now what is trivial subspaces? Okay, now see what is trivial subspace. So suppose this is V. We all know that V is a subset of V itself, right? V is a subset of V itself. So what is vector V? V is vector space. So if this is the vector space, this is also a vector space because they are same, na? So one is a subset of other. What we say here? If W is a subset of V, if W is a subset of V and W is a vector space, then we say that W is a subspace. So here what we are writing, W is a subset of V and both are vector spaces. So V is automatically a subspace. So V is automatically a subset. And then we know that what is the condition for existence of additive identity? 0 bar should be in capital V. So if we take a single element and make a set here, okay, this is the set, singleton set 0 bar. So first condition is this is subset of V, and all the 10 condition of vector space, if you try, then you see that it will be satisfied. Like first condition is what? 0 bar plus 0 bar is again 0 bar. Okay, so this particular set, though we have only one element, but it satisfies all the 10 condition. So this is also a vector space. So V and 0 bar are automatically subspace. No need to show. So wherever you see V and W, you can say that they are subspaces. So these 2 subspaces are called what? Trivial subspace. Okay. So I hope the definition of subspace is clear to all of you. Now let us do some examples. So examples are very, very easy. Show that the set W of all elements of the vector space V3 of F. Now this is interesting. What is V3 of F? Till now we are writing V of F, V of F. Then what is V3 of F? V3 means the elements are 3-dimensional. Suppose if you take a element V from capital V, then this particular element, no, this will be of the form, suppose X, Y, Z. There will be 3 elements. So it's a 3-dimensional. And F is what? Field. Now, show that the set W, okay, of all elements of the vector space, what? V of F of the form X, Y, Z belongs to F. So what does it mean? It means what here V is 3-dimensional, okay? V is 3-dimensional. Now, suppose W is a what? Initially W is a subset of V3 of F. So if W is a subset of V3 of F, that means what? All the elements of W are also what? Are also 3-dimensional. But here there is a condition. We should not break it. Okay. So if suppose we have taken an element X, Y, Z. Okay. Now this particular element is an element of V3 of F. Now the same element will come in W or not. If the condition is like this, if x, y, z are from field, if you take x, y, z from other set, then it will not be W. So take 3 elements from field and then make a pair, then this element will be in what? W. Okay, this element will be W. Of the form, here's one thing is missing, so let me correct it. Okay, so that's why of the form x comma twice y comma 3z, it is like this. It should be like this. Okay, x, y, z, they are from F. So here whatever I'm writing, it should be like this. Okay, so let us see it again. So W is a subset of V3 of F. Okay, W is a subset of V3 of F. Now what kind of element will be in W? If that particular element will be of this particular form, x, twice y and 3z. Okay, if this is the form, then this will come in W. Now what to show? We have to show that, W is a subspace of what? V3 of F. So for subspace, what is the condition? So from W, we have to take 2 elements, suppose U, V. Okay. For field, from field we will take 2 elements, suppose alpha, beta, and then combine them, alpha U plus beta V. And if we can show that this particular element comes in W, then W is a subspace. This is the theorem that I am talking about. Okay. So what to show? We have to show that W is a subspace. तो जिसे सबस्पेस दिखाना है तो वहां से हमें 2 एलिमेंट लेना होगा. सपोज U, W, U, V बिलोंग्स टू W. तो यहाँ पे क्या था? W में कब आएगा? इफ द एलिमेंट इज ऑफ दिस पर्टिकुलर फॉर्म x, ट्वाइस y एंड 3z. तो U और V ये W में है, तो उसका मतलब U must be of that particular form. Suppose it is x1, 2y1, 3z1. Okay, and then V will be of this form, x2, 2y2 and what? 3z2. And what about x1, y1, z1 and x2, y2, z2? They are all elements from field. And let us take 2 scalar, alpha comma beta belongs to F. Okay, now let us combine them, alpha U plus beta V. So alpha into U कितना था? x1, 2y1, 3z1, beta into what is V? x2, 2y2 and then what? 3z2. Okay, now how will I write it? See, alpha into x1, okay, alpha into x1, then plus, here we have to take the first element, beta x2. So the alpha into x1, beta into x2, that we can write together. Now, alpha into 2y1 plus beta into 2y2, comma, the third element, alpha into 3z1 plus beta into what? 3z2. Okay, we can write like this. Now this particular element must come in W, otherwise you cannot say that it is a subspace. So W में कब आएगा? इसका फॉर्म ऐसा होना होगा x, then 2 into y and 3 into z, but for the timing it is not of that particular form, but you can make it. You see, first element is suppose alpha x1 plus beta x2. Okay, then from the second element, no, we can take 2 common, then it is alpha y1 plus beta y2 and then take 3 common, alpha z1 plus beta z2. Now you see, suppose this is x, okay, this is x, then this is, you see, 2 into x and this is what? 3 into y. So this is of the form x. So if we consider that this time is x, so this is x and this is 2 into suppose y and this is what? 3 into z. अगर उस फॉर्म में है, बाकी कुछ चेक नहीं करना है, अगर उस फॉर्म में है x, twice y, 3z, then automatically we say that this is belongs to W. Now if alpha u plus beta v belongs to W, बहुत ही simple है. If alpha u plus beta v belongs to W, then we say that W is a what? Subspace. So therefore W is a what? W is a subspace of what? V3 of R. So it's very simple. जस्ट सबस्पेस दिखाने के लिए दो एलिमेंट लेना है, फील्ड से दो एलिमेंट लेना है. तो देन आफ्टर दैट वी हैव टू फाइंड अल्फा यू प्लस बीटा वी. जो भी क्वेश्चन में दिया रहेगा अगर उस पैटर्न में आता है और वो अगर W में है, देन W इज ए व्हाट? सबस्पेस. ओके, नाउ लेट अस टेक वन मोर एग्जांपल. नाउ इन द प्रीवियस प्रॉब्लम इट इज गिवन दैट x, ट्वाइस y, 3z उस फॉर्म में होने से W में रहेगा. बट हियर suppose prove that the set W of all the elements of the form ABC में रहेगा. और एक एक्स्ट्रा कंडीशन है, if it is of the form A, B, C, that is not the only condition. There is one more condition, A plus B plus twice C must be equal to how much? 0. अगर ये कंडीशन सेटिस्फाई होता है then only it will come in W. So what is W? W is a three-dimensional set A, B, C such that A plus B plus twice C, it should be how much? 0. Okay, then only the element ABC will come in W. Now what to show? To show that W is a subspace of what? V3 of F. So here also you see V3 means all the elements are three-dimensional. Now it's very simple. टू शो दैट W इज ए सबस्पेस हमें पहले क्या करना होगा? दो एलिमेंट लेना होगा. सो U, V बिलोंग्स टू W और दो स्केलर लेना है अल्फा बीटा बिलोंग्स टू व्हाट? F. नाउ U का जो फॉर्म है वो क्या होगा? सपोज A1, B1, C1. सो ओनली थ्री डायमेंशनल होने से नहीं होगा. सच दैट A प्लस B प्लस ट्वाइस C, सॉरी A1 प्लस B1 प्लस ट्वाइस C1, इसको कितना आना है? इट शुड बी व्हाट? 0. ठीक है, इसको 0 होना है, नहीं तो ये उस सेट में नहीं आएगा. सिमिलरली व्हाट इज V? V इक्वल्स टू सपोज A2, B2, C2 such that A2 plus B2 plus twice C2, this should be equals to 0. Now let us combine them. Alpha U plus beta V. So alpha into our U is A1, B1, C1 plus beta into A2, B2, C2. Okay. Now after combining, what we'll get? Alpha A1 plus beta A2, comma alpha B1 plus beta B2. One more element, alpha C1 plus beta C2. Okay. Now you see this is three-dimensional. A, B, C, but this will not come in W until this condition is satisfied. A plus B plus twice C equal to 0. So here in our case this is A, this is B, and this term is what? C. So now what to find? A plus B plus twice C. So हम लोग उसे निकालेंगे. Our A is alpha A1 plus beta A2. This is our A, plus then B, alpha B1 plus beta B2, then plus 2C. Our C is alpha C1 plus beta C2. Okay. Now can we take alpha common? So if we take alpha common, what we'll get? Alpha A1 plus B1 plus 2C1. Okay, यहाँ से 2C1 आएगा. Similarly let us take beta common. Beta common लेने से क्या आएगा? A2 plus B2 plus twice C2. Now you see this is equation 1 and this is equation 2. From equation 1, the first part is 0. From equation 2, the second part is 0. So this is 0 using 1 and 2. Okay, using 1 and 2. Now see, now alpha U plus beta V is three-dimensional. Also it satisfies that particular condition. Now only you can say that alpha U plus beta V belongs to what? W. तो अगर अल्फा यू प्लस बीटा भी W में आता है, सो व्हाट डज इट मीन? W इज ए सबस्पेस ऑफ व्हाट? V3 of F. So we did two example. In both the example we see that W is a subspace. तो हमेशा ही क्या सबस्पेस होगा? सो ऐसा भी एग्जाम्पल हो सकता है जहां पे सबस्पेस नहीं होगा. सो लेट अस टेक वन सच एग्जाम्पल वेयर यू शो दैट W is not a subspace. Okay, तो subspace नहीं होगा. So let us take this particular example. यहाँ पे जो field है वो capital R है. In the last two problem, the field is F, but here the field is R, so real number. And W is three-dimensional. See, X, Y, Z. But there is one condition. What is the condition? X, Y, Z should be belongs to Q. Q is what? Q is set of rational number. So I think you will all know what is a rational number. Rational number means what? Any number which is of the form A by B. Okay, A by B form में आने से rational number हो जाएगा. But here what to show? Show that it is not a subspace. Subspace नहीं है मतलब ये vector space नहीं होगा. Okay, this is not a subspace means this is not a vector space. तो vector space में क्या 10 conditions था. अगर कोई भी एक condition यहाँ पे satisfy नहीं होता है, then you say that W is not a subspace. कोई भी एक condition दिखा सकता है. Okay, so let us try. Now here capital R ये क्या है? Field. Okay. So let us take an element alpha. Field से हम लोग क्या लेते हैं? Alpha. So alpha equals to suppose √2 belongs to R. So this is what? An irrational number, because in real number is a combination of rational and irrational. So you can take any number. So alpha यहाँ पे हम लोग √2 लिए. And let us take an element U from W. So W का element 3-dimensional होगा और x, y जो z है वो कहाँ से आएगा? Set of irrational number. Now let us multiply with the scalar alpha u. Let us find alpha u. So our alpha is √2, and this is what? Or you can take some numbers also, then you'll understand it better. Instead of x, y, z, suppose 2, 3 by 2, and then suppose -5 belongs to what? W. We can take any number. You can take x, y, z also. No harm. So you see 2, 3 by 2, -5. These are all rational number. 3 by 2, then -5. These all belongs to Q. Now if you combine them, 2, 3 by 2, and then -5. After multiplying, what you will get? 2 √2. And then √2 into 3 by 2. So after multiplying, you will get 3 by √2, and last one is -5 √2. Now see, this is a 3-dimensional element. So what is said? X, y, z. If it is 3-dimensional, and if x, y, z belongs to Q, then only it will come to W. But here 2 √2, 3 by √2, these are not rational number. These are all irrational number. So this will not come in W. Now you see alpha u, ये कौन सा condition था? Closure property under multiplication. तो vector space का ये condition है. So vector space का अगर condition satisfy नहीं होता है, so that means what? W is not a vector space. अगर vector space नहीं है तो subspace ही नहीं होगा. So W is not a what? Subspace of V3 of F. This is not a subspace. So the examples are very, very simple. Okay. So we have taken two examples where we show that those are examples of subspaces. And then last में हम लोग एक example लिए, वो क्या नहीं है यहाँ पे subspace नहीं है. So इसी तरह आप लोग किसी भी book से numbers of problem हम लोग कर सकते हैं. Okay. So I hope you understand what is subspace, and thank you for watching today's video. So if you like my lectures, then kindly subscribe and share, and also hit the notification bell so that you get the notification of all the upcoming lectures. And if you have any query, then kindly post in the comment box. And thank you once again for watching.